So yeah, first missing and repeating. Okay, so given an unsorted array of size n of positive integers, okay, one number from set 1 to n, so the number starts from 1. Okay, 1 to n is missing and one number b occurs twice in the array. Find these two numbers, and the numbers are positive. Okay, so the numbers are positive. Okay, that's fine. We are given an array. Okay, it's not sorted, but one thing that we are sure that it will be in the set 1 to n. So, and in this set, like one number is repeating, while one number, so if one number is repeating twice, then probably the one of the numbers in the set 1 to n will be missing. So suppose let's have an example like we are having 1 2 3 4 5 and say one more 5. So 1 2 3 4 5 5. So here 5 is repeating, and 6 is missing. So since we only need to deal with this, since in the constraint there is only positive numbers. So what we can do means we can create a count array or an array. Okay, let's have this array which is of size say n plus 1, because there is no 0, and for array it's always 0 indexed. Okay, so we start from 0 1. Okay, so these are indexes, so let me have it the other way around. Okay, so these are 0 index, first index, second index, this is the third index, this is the fourth index, and this is the fifth index. So 1 2 3 4 5 6. Okay, so we are having n plus 1, so we need one more, and this is the sixth index. Okay, now we have 1, so to this 1 we will be having a count 1, this 2 we will be having a count 1, this 3 we are having a count 1, this 4 we are having here a count 1, this 5 we are having a count 1, and again this 5 is coming, so the count is now 2, and after that, like, there is no elements, so this 6 will be having a count 0. So now what we can do means we can just go through this array once, starting from the first index, because our set is having a number from 1 to n. It does not include any 0, so we are having from 1 to n. So we can just go through and can find that number which is having a count, which is greater than 1. So 5 is having a count greater than 1, so that's the repeating one, and we need to find that number whose count is equal to 0, and that number will be our missing number. So that's one of the way, but here we need to make use of an extra space. So we can do this, then the time complexity here will be big of n, and the space complexity will be, as we are keeping track of the count, the frequency, we are making use of another big of n space complexity. But we can also just do this, but our expected is big of 1, so big of 1 means like we have to do it in place, some kind of an in place algorithm have to be achieved or have to be done, so that we need to get rid of this frequency array. So that's what we need to do. So let's again take the example 1 2 3 4 5 5. One thing to note is, like, this is not sorted, but I just took an example like that. Okay, so what we can do means, let's try to change, like, whenever we visit a number, let's change that number to some negative value. Okay, since we are sure that there will not be any negative value, okay, based on the constraint we are only having positive number. So if we visit that number, let's change it to -1. Let's change this to -1, -2, -3, -4, -5, and when we reach here, we already visited it and we changed to -5. So that means this number is the repeating one, and this I plus 1 is the, so let me try to give it more. 1, 2, 3, 4, 5, 5. So we take number 1. Okay, so we take 1 and we just check whether 1 is greater than 0. So if 1 is greater than 0, what we are doing means we will be making nums of whatever be the I -1, because our array is a 0 index array. We are making it to a negative value, negative nums of I -1. Okay, so 1 is greater than 0, that means nums of 0, that means nums of 0 is made as minus nums of 0. So that's what I meant here. So this will be -1. This is the 0th index, this is the first index, this is the second index, this is the third index, this is the fourth index, and this is the fifth index. Okay, so the first index is made 0. Okay, fine. Now we take the next number. Now we take the next number, which is 2. We check whether 2 is greater than 0. 2 is greater than 0. Yes, so we'll be doing nums of 2 minus 1, nums of 2 minus 1 equal to minus of nums of 2 minus 1, which means nums of 1 is equal to minus of nums 1. That means we are just changing this to -2. And same way we will be changing this to -3. We will be changing this to -4. We will be changing this to -5. Till here we are okay. Now again the next number is 5. Okay, the next number is 5. So we just check whether 5 is greater than 0. We are just checking nums of whatever be this number -1 is greater than 0, which means whether nums of 4 is greater than 0. No, nums of 4 is not greater than 0, because we have already visited and we have made it as -5. So this is the number which is repeating. Now how to find which is not repeating? So whatever in which index we are having the positive value, that number will be repeating. So that's it. So let's have, so if array is equal to null, or n is equal to 0, let's say return an empty array. Let's have missing and repeating. So what the first number which is missing, okay, repeating, which is equal to new int of 2. Now let's get with traversing through the numbers. So for int number from ARR, if ARR of number -1, because we need to do -1 because we are having a 0 base indexing in this array, but our number starts from 1. So there will be always a +1 number. So the indexing starts from 0. So we need to number -1. In this first the case itself, this is actually at the index 0. So we have to do array of 1 minus 1. So that's the idea here. So if it is greater than 0, we are just making it as a negative value, minus ARR of number -1. else we get the missing, which is else missing and repeating of 0 is equal to number. So that's the number which is getting repeated, and we can just break because we are sure that there will be only one number that is repeating. So there is no point of again going to the rightmost side for checking is there any missing or repeating. So we get repeating actually here. Okay, we get repeating, but we are still not sure like which number is missing. So we can just again go through for int I is equal to 1, I less than or equal to n, I plus plus, if AR of I minus 1 is greater than 0, if it is still positive, then our missing and repeating of 0 is that I, and we can break. Now we got both the answers. Now just return missing and repeating. So here we are going through the array once here, so big of n here, and this is also big of n, and the best case scenario, so the total complexity will be big of n plus big of n. Still, like it's big of 2n, which is also big of n. We can say it's big of n itself. And we are here, like the previous case, we are not making use of any frequency array. So so that case we were using extra space, but here we are just doing an in place change of the number to -1 in order to indicate that we visited that number before. So yeah, that's the idea, and let's try to run. Is there any mistake? We are having array index out of bound. Okay, array of I minus 1, we are having at line 39. Okay, if array of number minus 1 is greater than 0, so yeah, we need to, because that's the case where 90 numbers occurs, we need to take the absolute value of number. Yeah, my mistake, sorry. Because if a number was repeated, yeah, here we got we made it the other way around. So this is 0, this is 1. So this is the repeating number, this is the missing number. So let's also name it repeating and missing. Let it be like that, repeating and missing, repeating and missing. So repeating and missing. So why we do an absolute value here? Okay, so here we need absolute value because the number will be negative. This number will be negative, and if we take that number -1, like it will be will go to negative. Like if we have a 4 or a 3, if we already visit that, then it will be a negative number. Code is failed, correct output is 30, and I'm getting it as 2. Okay, it's array array of I minus 1, missed here. Output is 2. And missing of 1 is array of I minus 1. So it's because we break there. Okay, that was the mistake there. So let's not break there, then it will be fine. Your output is 2 1, sorry, 4 I minus 1. Okay, I think now it's will work. The idea is still same. I just removed that break here. Yeah, now okay. Sorry, like I just thought break, but that will not be the case, because if you do a break, like still we are not sure like which is the missing number, because the other numbers will still be 0, will still be greater than 0. So like we will get wrong answer. So yeah, this is the idea. Like just if it is visited, just make that numbers, like, because we are sure that our number is from the range 1 to n. So let's change that index value into a negative value. So if it's again comes and if we see that it's negative, then that's the repeating value, because we have seen it before and it is again occurring again. So yeah, so that's the idea.